Hi guys, and welcome back to another episode of the data series. In this episode, I plan to show you guys how to evaluate your classification algorithm in Python. So the first step is to actually build the classification algorithm. And for this, we're going to be using the same algorithm which we built on episode 9.4 of nonlinear support vector machines in Python. So I'm just going to go through this code fairly quickly as we have done this before. So first I import warnings and then put a filter here to ignore any warnings that pop up. I import pandas as PD so that we can read our data into Python. The data and code is available on GitHub and should be provided in the description below. So here I've saved the data under the file project data and it's called pulsar_data.csv. We save the data under the variable name start_data. We drop any rows containing missing values. We also remove spaces in the column headings. We then define our input data X and our labels Y. We then perform data standardization to improve the performance of our nonlinear support vector machine. We then split our data into training and test data. And then lastly, we actually build our support vector machine. And for this, we're using the RBF kernel and we fit it to our training data. And lastly, we get a set of predictions here. So now that we have built our classification algorithm, we can now go on to evaluate it and look at the different evaluation metrics which we've gone through in the previous episode. So I've just written some code here that gets us the true positives, true negatives, and false negatives. So for this, I've imported the confusion matrix from scikit-learn. And for this, we just pass in the two parameters, yTest, which is our actual y values, and yPredict, which is our set of predicted values. And these are calculated to be used in some of the evaluation metrics below. So we start off with accuracy, and for this we can just import the accuracy score function from the scikit-learn, and we just simply put in our actual y values and predicted y values. A lot of imported functions just take our actual y values and our predicted y values. So here we pass this into the accuracy score. We get an accuracy of roughly 0.98. We can also look at our precision here, same concept, but this time importing precision score. We can also look at our recall. We see here that our recall is slightly lower, showing that our model has some false negatives. So here we have a very low false positive rate, suggesting that we have a low number of incorrect predictions on negative data points, i.e. a low number of false positives. And we calculate the false positive rate here using our false positive and true negative variables that were calculated here. And we can also calculate specificity by using the specificity formula. And for this, we get quite a high value. We also have sensitivity, and this is just the same as recall. We also have the F1 score, which gives us the harmonic mean between precision and recall. And for this, we get a reasonable score of roughly 0.88. And for our final evaluation metric, we look at the AU-ROC score, which looks at our model's performance over different decision boundaries. And for this, we import metrics from the scikit-learn library. We give it our classifier, our input test data, and our test labels. And we can use the plot_ROC_curve method to plot our ROC curve. It also gives us the area under the curve, which is a high value of around 0.96. You can get the exact AU-ROC value by importing this function here. But this time, when we pass the parameters, we look at our actual y values, and we also calculate our decision function on our test data. So that's pretty much it for this episode, and I hope you learned something new. In the next episode, I plan to do another data science project. Thank you guys again for watching. If you have any questions or comments, please leave them below.